Good morning, everyone. Let's continue with the discussion of hypothesis testing that we started in the last class. What I'm going to do today is kind of give you an overall overview of hypothesis testing and do a little bit more of definitions and then start doing the problems, okay? And then we'll continue working on hypothesis testing problems to the point where you should be confident in doing all these problems. So first of all, what is a hypothesis testing? Simply speaking, hypothesis testing is testing something about the population, okay? Hypothesis testing is testing something about the population. Now, what could that be? Typically, we test the population mean, that means population average, like average number of years that the college students take to graduate from a four-year institutions in the US. That could be one testing, or average number of years two-year college students take to graduate from the college, right? That's testing the average for a population of college students. Or you could think of testing something about proportion or percentage. What percentage of the people believe in abortion in the US or any other country or any location, whatever it may be under consideration? Or what percentage of people believe in equal rights? Okay, equal rights for people of color or people with different gender or ethnicity, things of that nature. So that's another type of hypothesis testing that involves proportion. Or you could think about testing the standard deviation, even though we test for variance and then we conclude about standard deviation. You as an owner of a company, you might be thinking you are making some gadget, let's say, all right? You are making toys, let's say. You might be interested in the variation of the amount of time it takes to make a product, okay? Or in essence, you're finding the variance. So that might be of something interesting, because if you are the supplier of a toy to, let's say, Target or Walmart or any big chain store, you have to give them a time, right? They want 1 million piece of this. Okay, this particular toy, they want 1 million piece. Now, they need to you need to give them a time. You know that your variation could be up to let's say 60 days or 2 months. Okay, then you give them time in such a way so that you can fulfill your commitment. Some examples that I'm giving you, but these are very simple examples, but in the real world, they use the concept of variation in a more sophisticated way, okay? So if you just paid attention to the discussion that I was having, again, we have done the PMS thing, PMS. Do hypothesis testing for proportion or percentage, do hypothesis testing for mean, and do hypothesis testing for standard deviation. Do hypothesis testing for standard deviation. So you're going to do hypothesis testing for population proportion, hypothesis testing for population mean, and hypothesis testing for population standard deviation. The PMS acronym, it helps us again. And what is hypothesis testing? It is testing some characteristic or attribute or property of the population, or in layman's term, testing something about the population. Hypothesis testing is testing something about the population. And remember one thing, please, you never test anything for the sample, okay? You don't do hypothesis testing for sample. That's what I meant to say. You don't do hypothesis testing for sample, but rather you collect sample data or you do sampling, and based on your data collection, you make some conclusions or predictions in some cases, about the population. In our case, right here, in hypothesis testing, we are going to rather do conclusions, not predictions, okay? All right, enough about hypothesis testing. When you are so what is a hypothesis testing? A hypothesis, what is a hypothesis? Okay, a hypothesis is a claim about population parameter. So what population parameters we are talking about? These guys, proportion, mean, and standard deviation. These are parameters, and in general, it's denoted by theta, okay? Generally speaking, the general term or generic term for parameter is theta. Theta, generic symbol that we use for population parameter is theta. Now that theta could be proportion, theta could be mean, and theta could be standard deviation. So a hypothesis is a claim about population parameter that is presented in terms of a mathematical relation. So we present hypothesis in terms of a mathematical relation. Hypothesis is a statement about the population that's presented as a mathematical relation so that we can do testing about it. Now, there are two types of hypothesis, meaning one is null hypothesis, another is alternative hypothesis. Null hypothesis is the default or given hypothesis, what is given to you, okay? If you compare it with the criminal justice system, null hypothesis is the default assumption that an individual is innocent. Null hypothesis is the default assumption that an individual is innocent. And alternative to that would be that the individual is guilty. So null hypothesis is innocence, alternative is guilty. Or null hypothesis could be mu, let's say mu, average number of years students take to graduate from two-year institutions is, let's say 2.5, okay? Average number of years that the students take in order to graduate from two-year institutions is 2.5. That's known. That's what people believe in, okay? That's kind of given to you. That's your null hypothesis. That is your null hypothesis. Null hypothesis, by the way, is denoted by H sub 0. That's just a convention. It is denoted by H sub 0. Null hypothesis is mu is equal to 0. Now the alternative would be mu is not equal, sorry, no, I didn't mean to say mu is equal to 0. I meant to say mu is equal to 2.5. Alternative is that mu is not 2.5. That's one option. Or you could also test for mu is greater than 2.5. That means average number of years that the students take could be greater than 2.5. Or the other option is mu is less than 2.5. That means the average number of years that the students take in order to graduate from college is less than 2.5 years, greater than 2.5 years, or not equal to 2.5. That means it could be either greater than 2.5 or it could be less than 2.5. All right. So these are the three different scenarios that you will be testing for or looking for against this. Now, if it is less than, by the way, if you're dealing with less than, this would be left tail test. Left tail test. If it is greater than, it will be right tail test. If it is not equal to, then you have to consider both tail test. It will be both tail test. So left tail test, right tail test, and both tail test. That's what it is. So far, is it okay? about the definitions and terms? Everybody okay? Any questions, anyone? Alicia, any question?
No questions so far.
Okay,
So far.
great. Please let me know if you have any questions. Don't hesitate. So we are going to be doing left tail, right tail, or both tail test. Now, alternative hypothesis is the complement of the null hypothesis. We just talked about it. Alternative hypothesis is the complement of the null hypothesis. This is not necessarily a true complement we consider all the time. Like in the true complement sense, if you're thinking about, let's say mu is equal to some value a, the true complement is mu is not equal to a. But we do test also mu is greater than a or mu is less than a, okay? But generally speaking, alternative, we kind of say that it's the complement of the null, all right? And this is something we talked about, null hypothesis, whatever is the default value that's given. One important thing is this, when you're doing the hypothesis testing, you do not try to justify or kind of collect data to ensure that the null hypothesis is true. You don't have anything to prove there. It's given. H dot is always given to you. What is already given, you don't need to collect data or you don't need to prove it right or wrong, right, okay? All you try to do is prove that it is wrong. That's basically what it is, okay? You don't collect data or information in support of the null hypothesis, but rather you collect data or information that would be against the null hypothesis. That means that would prove the null hypothesis wrong or unacceptable. That's what you do. Because something which already is known, you don't need any justification to justify that, oh, okay, that's the number. So if you are given that the average number of years that the students take in order to graduate from 2-year college is 2.5, you really are not trying to prove it again, okay? Because this is already accepted, okay? This is an accepted value. You don't need to justify it again. What you want to justify, however, is that this number is different, okay? Either it's greater than, or it's less than, or it's not equal to, which means it could be either greater or less. So you don't need to justify the same thing again and again. All right. And this is what I talk about here now, an alternative. Now, when we're doing hypothesis testing, we are gonna go through a few steps. So let me just try to kind of write it down. Number one is assumptions. You have to make sure that the distribution or sampling distribution is bell-shaped or normal, okay? Your sampling distribution is bell-shaped. Number two is what is your null hypothesis, null and alternative hypothesis. Oops. Okay. And number three, you do test statistic calculation. It's not statistics, it's test statistic calculation. Okay. And number four is that you find the critical regions. And number five is you make conclusions based on your test statistic and critical region comparison. You make conclusions. Okay, now this conclusion could be made in two different ways. One is through critical region, which let's call it critical region CR. another is through something called p-value. And I'm going to show you both of these techniques to make the conclusion. Well, they essentially or definitely always lead to the same conclusion, whether you go through the critical region or p-value. All right, then next, there are two types of errors that you can make when you are doing hypothesis testing. Let's say a person goes into the judiciary system is innocent, okay? But we find him / her guilty. The person goes on a trial, but in reality, the truth is that the person is innocent. But what we do through the judiciary system, we make the person guilty and punish him or her. We made a mistake. And that type of mistake is called type 1 error. Okay, that type of mistake is called type 1 error. On the other hand, there is another kind of mistake. Okay, another kind of mistake. Let's say the person, the truth is that ground truth. Let's call it ground truth. Okay, ground truth is that the person is actually guilty. Okay, person committed some crime. Okay, person committed some crime that's guilty. In that case, what we do, the person goes to the judiciary system and the trial and everything, and the person is found, so action, let's call it action, okay? Ground truth is guilty, but the action was innocent. In that case, we also made an error, and that's called type 2 error. Type 2 error. So we have type 1 error and type 2 error. So this is something you should know. Now, type 1 error, I go about this thing a little bit more, okay? Type 1 error, where is it? Right here. Type 1 error happens when we reject the null hypothesis when we should not have. Okay, this means that the null hypothesis is correct, but we mistakenly rejected it. And type 2 error happens when we do not reject the null hypothesis when we should have, that is, the null hypothesis is incorrect, but we fail to reject it, okay? Another thing we kind of need to know, type 1 error, okay, is associated with significance level, okay? And also known as alpha, okay? Alpha. Type 1 error is associated with significance level, and we are dealing with alpha. And type 2 error is also called beta, okay? So beta is not associated with significance level, it's rather associated with a bigger region, okay? So if you talk about the null hypothesis, I mean, normal distribution, and then this is your critical region, or this is your alpha values together. So type 1 error associated with alpha and type 2 error associated with the middle. You can think of it that way. Type 1 error or alpha is the one that we will be dealing with. Type 2 error is much harder to detect, okay? And there is a whole field of analysis and study about type 2 error, and that's more advanced, and we don't go into that beta error or type 2 error. Okay. Let's move on. Now we are going to be in our PMS structure. We are actually going to do proportion, mean, and standard deviation. We are going to do hypothesis testing for proportion. We are going to do hypothesis testing for mean and hypothesis testing for standard deviation. So first we are going to do hypothesis testing for proportion. So remember that PMS acronym. One of the things that you need to be very clear about is the central limit theorem. Okay, under certain conditions, sampling distributions become bell-shaped. When the sampling distribution is bell-shaped, that's when we can study things, because bell shape is a shape for which we understand many things. If we convert anything to bell shape, that means we have more control over it. Okay, that means we can study that population. Now, the 5 steps that or 5 requirements that I talked about are 5 or 6, I think 5. One is the insurance of, you ensure that sampling distribution is bell-shaped. The way you do it by ensuring that n times p, n is the sample size, p is the population proportion, is greater than 10. Change that number to 10, please. And then n times 1 minus p, which is greater than or equal to 10. The reason I put it 5, I think somewhere along the line, I may have seen it, okay? I think for population hypothesis testing, it could even be 5, all right? But we just wanna be on the safe side, it's fine. We leave it what is more acceptable, which is 10, okay? So let's go ahead and make it 10. These 2 assumptions have to be true, okay? Before you do hypothesis testing, you have to make sure that these 2 assumptions hold true, okay? These 2 assumptions hold true, not one or the other. It has to be both. Keep in mind that it's not one or the other, it has to be both, okay? So that's what it is. And the null hypothesis and alternative hypothesis. Null hypothesis is P is equal to P naught. P naught is some fixed value. P is the population proportion, okay? I could say P is 30%, okay? So in that case, P naught would be 30% or 0.3. So that's what it is. And the alternative could be P is not P naught, sorry, this should be P naught. So there's a bit of typo here, and change it to P naught, okay? It's not 0. P is greater than P naught, P is less than P naught, and P is not equal to P naught. So these are the 3 scenarios for which we are going to do hypothesis testing. These are the 3 scenarios for which we are going to do hypothesis testing. Now, the next step is that test statistic. We are going to do the calculation for test statistic, okay? Now, test statistic is something this. P hat minus P over square root of P times Q. By the way, Q is nothing but 1 minus P, okay? The complement of P. 1 minus P, all of it divided by sample size n. This, by the way, has approximately normal distribution with mean of 0 and standard deviation of 1. And here, by the way, I'm giving you guys some examples that are, or some discussion that I'm having that, by the way, are a bit more advanced, okay? It's not exactly required the mathematical derivation or formulation of hypothesis testing for this class. So we just need to do hypothesis testing, but I'm kind of sprinkling a little bit of theory behind it, okay? As it turns out, using the sampling distribution, okay, using the sampling distribution, if your sampling distribution is bell-shaped, which is ensured by this p hat minus p over square root of p times q, or p times 1 minus p over sample size, that has normal distribution, standard normal distribution with mean of 0 and standard deviation of 1. Now you will find the critical region in step 4. Okay, critical region is the region that will determine whether you will reject or do not reject the null hypothesis or the given assumption, whether you will reject or do not reject the null hypothesis or the given assumption. And remember from last couple of weeks of discussion, significance level alpha, okay, we talked about it. Alpha is 1 minus the confidence level, right? Alpha is 1 minus the confidence level, which is the significance level. Basically, significance level has, so in layman's term, significance level tells you what are the chances that in a random scenario you will, okay, you will get the conclusion wrong. That's what it is. That's how you should be thinking about significance level. Significance level is your chances of being wrong, given that you followed all the procedures and everything, right? Yet you get to the wrong conclusion. Like in a justice system, let's say that the justice system follows the fair trial and everything, okay? But turns out that they also make mistake, even with all honesty and everything, they make mistake. And alpha is that chance or that probability of making mistake, given that everything is done properly, or in the justice system, things were done in a fair way, in an unbiased way. That's what it is. So that's what alpha is. Alpha is the significance level, or the level. Alpha is the significance level, and the level for which basically tells you your chances of being wrong, or the probability of being wrong. When alpha is, let's say, 0.05, that tells you there's a 5% chance of being wrong. Or if alpha is 0.01, that tells you there's a 1% chance of being wrong in the process or in this calculation. And then you make conclusions based on your critical value and the statistic that you calculated. All right. And this I made it an extra number. This is actually a conclusion 2. You don't have to cancel it or cross it. It's the same thing. This conclusion you can make based on critical region, or conclusion you can make based on p-values. And I'm going to do both of them for you. So this is the whole process. Now I'm going to be doing this whole process so many times that you'll be like, oh, okay, I had enough of it. All right. So let's go ahead and start working on problem. But one of the things I kind of want to talk about right now, is a good time to talk about it, is the justice system and hypothesis testing, right? Justice system and hypothesis testing. There is a trend around the world, okay, where we use artificial intelligence, okay? Some countries already started to implement this. We know that we have so many questions and so many things with the justice system about fairness and everything, particularly when it comes to minorities and treating them fairly. If we can create an AI or artificial intelligence system that could decide what the verdict should be based on the evidence, of course, we will have to hide information such as race, ethnicity, gender, okay? It is probably gonna be the case in next decade or so. There are many low-level crimes. It could be the verdict could be given by AI, and then maybe a human judge or human jury kind of like evaluate this, whether it's right or wrong, grossly. Okay. Even though a lot of people talk against it being biased, you guys may or may not know. A lot of people say it might be biased against the minorities and this and that. But I think in the real world, if this is designed and defined properly, it will actually help people who are minorities. The reason is that many of the human biases are going to go away. Okay. There are so many human things come into play that's not even funny. I was called for jury duty a couple of times when I was in Salinas, and I went there, but I wasn't selected. They bring in these people, and when you look at a human, okay, as a human, you look at another human. Doesn't matter who you are. You can say all the things, I'm biased or unbiased. Subconsciously, you become biased based on your view, okay, of the person. If a person who looks shabby, who is improperly dressed and disabled, you might be more prone to make a negative decision about the person, even though the person may be completely innocent. On the other hand, somebody might be dressed up in tie and suit, and you might be thinking, oh no, that person is less likely to do the crime. But that's bias and prejudice. And I think through AI, we can address those. I think some Scandinavian countries, they're already doing things like traffic violation. They're these kind of low-level things that they just give it to AI. I heard of one country that is doing it already. You don't have to even go to court, given the circumstances. The artificial intelligence is going to decide whether you should be responsible for paying the ticket or you should be excused, given the scenario. One ironic thing about life is this. You guys probably have heard the verdict yesterday, and this is not a common verdict. Let's put it that way. This verdict has come in after a long process and many years of waiting. The brutality that's being inflicted on minorities. Just imagine what has happened to that individual. Okay, if nobody were to take the video, this thing would have been gone. Nothing would have happened. A lot of injustice is being done, but those gets unpunished a lot. So if we can somehow get artificial intelligence involved into the justice system, I think many of the biases actually could be removed, as opposed to, even though some people would argue that, oh, it might inject biases, but that takes a lot more deeper understanding of how this thing works. But that's all about it. So let's go back to our problems. All right, so this is a very interesting and very relevant problem. I talked about it last time and also today. Last time was Monday, and yesterday was the verdict, and today is again, I'm doing the same problem. Roots, a very popular TV show in the 1980s that depicted the lives of African Americans in the US. Roots is a book by Alex Haley. If you get a chance, please read it. It's a good book, worth reading. Anybody has read that book, Roots, in this class? Roots by Alex Haley. Anyone for any class? Anybody?
No.
No. If you get a chance, please read. Reading is a good habit. It'll make you knowledgeable. through reading, you can experience other lives, okay? You have only one life. That's all you can experience. Even if you want, you cannot have two lives. But by reading, you can experience many lives in your lifetime, okay? By reading, read. If you read a novel, you're actually reading someone's life. You are learning from their experience. If you're reading an article, you're learning about someone's knowledge that the person gained. So by reading, you can multiply your knowledge significantly. And one of the things I tell my students, and I don't know how many of you guys pay attention. One thing I strongly believe, and I believe I am right, is that the race problem that we are having in this country or around the world, the solution, the best solution is not like going into the streets. Yes, that might bring in some solutions, but I don't think that's the best solution. Best solution is educate yourself. That is the best solution. And once you educate yourself, get into business and finance. Business and finance. By that, what I mean is make money. Okay? If you have money, many of your problems are going to go away. And you are too young to understand it. Like, let's think about this. You're a minority, you get abused by police, right? You get mistreated by police. You can complain about it easy. Anybody can complain. If you're lucky, out of 1,000 or out of 100, your voice might be heard. But if you're educated and if you have money, one or the other or both, money is the main thing, okay? To get to money, you have to educate yourself, do business, and get to money. If you have money, people would think twice before mistreating you. As a matter of fact, your life will change significantly. Sit down and think about what I just said. If you're struggling in this world, main reason is money. And that struggles come from you not having money. And now, because you don't have money, people will mistreat you based on different things. In this country, it's based on race mostly, okay? But in other parts of the world, people will mistreat you based on your religion or based on your gender, okay? Or based on all of these, root cause of all of this is money, okay? If you have money, all of these discriminations will significantly reduce against you. And you have to have money collectively, not just, don't think that, oh yeah, I have hard arguments like this. Oh yeah, people like LeBron James or big black athletes, they have a lot of money. And that doesn't make a difference. No, when I'm talking about money, I'm talking about money collectively. One person could be rich, that's not going to solve the problem. If Michael Jordan or Steph Curry or LeBron James get into problem with the police, it's going to be all over the world in news. But if you get in trouble, it's not going to be anywhere. Okay? So when I'm talking about educating yourself, when I'm talking about having financial strength, I'm talking about collectively as a group, having money, having financial strength. Okay? Like America, collectively, we have money, we have financial strength, we have education. That's why people from all over the world, they want to come to America. Okay? It's not because the Bill Gates has money. That's why they are here. All right. Enough of this. I'm trying to bring awareness. So main thing, educate yourself. Education is extremely important. Extremely. I can't emphasize enough. So Roots TV show, it was very popular in the 80s. Okay. When I was younger, I saw that TV show briefly back where I grew up. And then we are trying to find out how many people or what percentage of people nowadays know about that show. Okay. What percentage or proportion of people know about that? So Now you surveyed 350 people, and that survey revealed that 150 have heard of it. Oh, sorry, 190 have heard of that show. So you surveyed 350 people, and out of that, 190 people said that they have heard of or seen the show. Based on this data, would you reject the null hypothesis? So this is the null hypothesis, given one, that percentage of people who know about the show is 50%, or P is 0.5. So you took a statement and you converted the statement into a mathematical relation. That's what the hypothesis is. If you go out in the ordinary and tell people, hey, do you know about roots? P is 0.5. They're going to be saying, what? But if you tell somebody, do you think the majority of the people know about the TV show Roots or the book Roots? That's the question that an ordinary person would understand. However, you need to take that statement and translate it into a mathematical equation so that you can do mathematical analysis on it. And that's exactly what we do in the null hypothesis. P is equal to 0.5. All right. And what significance level? 0.05 significance level. Remember, that is your alpha. Now let's do the first requirement. NP is greater than or equal to 10, and NQ, which is the same as N times 1 minus P, is greater than or equal to 10. Remember, both of them have to be true. N is 350, right? Times P is 0.5. So 350 times 0.5 is obviously greater than or equal to 10, no problem. 350 times Q is also 1 minus P, 1 minus 0.5 is also greater than or equal to 10. So these two conditions are satisfied, this one and this one. Therefore, normality condition is satisfied. By that I mean your sampling distribution of the proportions. Sampling distribution of the proportions is normally distributed, or sampling distribution of the sample proportions is bell-shaped. That's what it is. Now the second condition we are testing, P is equal to 0.5 or 50%, or alternative hypothesis. There is a typo here. This should be H sub A, not H sub 0. H sub A, alternative hypothesis, P is not equal to 0.5. P is 0.5 and P is not equal to 0.5. So if we go and label them, this is 1 and this is my 2 and this is my step 3. We are going to do test statistic. Test statistic is calculated by this formula Z star. We call it Z star, which is P hat minus P divided by square root of P times Q. Q is 1 minus P, all of it divided by the sample size. Now, what is P hat? P hat, remember, P hat is X over N. That comes from your sampling. You asked 350 people, that is your N, and X is 190 because out of 350, 190 of them said, yes, they agree. They have heard of or they watched the TV show Roots. So it's 190 over 350. That's P hat. So that's exactly what I have here. And P is 0.5, right? This 0.5. So then square root of 0.5 times 1 minus 0.5 divided by 350. All right. If you do this calculation, you get Z star is equal to 1.6. Z star is equal to 1.6. And that's what it is. That's your test statistic. Now, based on your significance level, you're going to find the critical regions. So now let's go ahead and do that based on significance level. So we are going to do two-tailed test because it's not equal to, right? So you take alpha, which is 0.05, you divide it by 2, divided by 2, that gives you alpha over 2 is equal to 0.025. Okay, so your right tail is going to be 0.025. Your left tail is going to be 0.025. Now, associated with an area of 0.025, you can look it up in the table, standard normal distribution table. You'll find the z value. So these values, this is mean of 0, is going to be negative 1.96. And by symmetry, because remember, normal distribution is symmetric about the middle, right? So left half is a mirror image of the right half. So this is going to be positive 1.96. So your critical regions becomes everything, okay? Your critical regions becomes everything from here all the way to negative infinity, and from here all the way to positive infinity, all right? And what does that mean? That means this: your critical regions are going to be from negative infinity to negative 1.96, which is left shaded region, this left shaded region. Union 1.96 to positive infinity, which is the right shaded region. That's what it is. That's your critical region. So these are critical regions. In this case, we have two regions. Normally, we could have either one region or two regions. When you are having one region, it could be either left region or the right region, or left tail or the right tail. Okay, if you are having both tail tests, in that case you will have two regions, one to the right and one to the left. And if you are dealing with two tail tests, you have to take the significance level and divide it by 2. But if you're doing one tail test, you don't have to divide the significance level by 2. Only if you are doing two tail tests, that's when you divide the significance level by 2. Now, your test statistic, remember that. Does that test statistic fall in the critical region? So let's go ahead and check it. So this is an important number. 1.6 is the test statistic. So 1.6 is a positive number, so it's not going to be to the left of 0, right? No, it's going to be to the right. 1.6 is going to be probably somewhere here, 1.6. So this test statistic does not fall to the right of 1.96 or to the left of negative 1.96. That means the test statistic does not fall in the critical region, left critical region, nor does it fall in the right critical region. Therefore, you do not reject the null hypothesis. So your conclusion, okay, step number, so this was step 4. Step number 5, which is conclusion. Your test statistic does not fall in either of these critical regions. Therefore, you do not reject the null hypothesis. Only time you will be rejecting the null hypothesis when your test statistic fall in the critical region. Okay? If your test statistic fall in the critical region, that's when you're going to be rejecting the null hypothesis. Now, that's step number 5, the conclusion. Now, we can do conclusion in a couple of different ways. One is through the critical region, which I just did, right? One is through the critical region that I just did. All right. The other is going to be through p-value. Now, let's talk about p-value. What is the p-value? That's one thing I kind of want to tell you, because in the industry, basically, people are not going to be doing the hypothesis testing using these steps. There are software tools that's going to let you do these calculations, okay, automatically. So you just give in the data and give in the significance level, it will automatically do all the calculations. However, you need to know what the steps involved in doing this calculation. That way you will get a better and solid understanding. Now, when you use a software package, a statistical software package, you will actually get something called p-value, and that p-value is this. So your alpha over 2, you're doing two-tailed test here, right? Alpha over 2 is 0.025, which is this is 0.025 and this is 0.025. Now your test statistic is right here, 1.6. Now look, if you consider the area to the right of this test statistic, which will be this blue shaded region plus this unshaded region, white background region. That means your p-value is greater than alpha over 2, okay, which is 0.025. So your p-value is greater than actually I will use including equal to. P-value is greater than or equal to 0.025. If that is the case, in that scenario, you will not reject the null hypothesis. Why? Because if p-value is greater than or equal to alpha over 2, it does not fall in the critical region, okay? It does not fall in the critical region. For if the p-value is less than alpha over 2, in that case, your p-value would be somewhere around here. In that case, your p-value is going to be everything to the right, okay? Everything to the right. Now, everything to the right from here is 0.025. So if you start from here, it's going to be smaller. So p-value is less than, when your p-val is less than alpha over 2, or in this case 0.025, you will reject. So you'll reject the null. Or on the other hand, if these two conditions are true, do not reject. Reject the null hypothesis. And that's what the p-value story is. So that's the complete explanation of a hypothesis testing. I know this is a lot of information. I'm recording it, watch it multiple times if needed. However, once you get the hang of it, it won't be too bad. Just do a bunch of problems again and again and again, it will start to make sense. First couple of times, it may not make sense. It's a bit confusing what's going on and whatnot. But if you do it multiple times, you will see it is gonna start to make sense. Okay, now any question, anybody, about this? Is it too much information? Can you handle it? Any question, anybody? Are you guys okay? Brandy, are you okay?
Yeah, I'm good. It's fine. I think it's you're explaining it really well. So the more we do it, the better we'll get.
Okay, thank you. Anybody else? AJ, is it okay?
Yeah, it's okay.
Anyone else? Okay. All right. In that case, I'll go ahead and continue with more examples. And if you have any questions, please let me know, okay? Please do let me know. All right, so let's clean up the screen first. Next problem. I'm gonna, I can do the problem again, but I'm gonna give you 5 minutes. I'm gonna give you 5 minutes to work on the next problem. Go through the 5 steps that I just described. Try it, okay? 5, 6, 7 minutes, okay? If you don't try it, you're not gonna get the feel for it, true feel for it. So I want you to try the problem. So please take a few minutes and try to solve the problem on your own. Then I will go ahead and do it. How many examples I have here? Let's say 2 more in this proportion category. And I will do both of them for you, not one, both of them. But I want you to try it. So please go ahead and try it. Take a few minutes, okay? Okay, guys, how is it going? The problem, this example on the top of the screen. Anybody has any questions? Any comments? Okay. So let's go ahead and read the problem. And as I go along, I will ask you questions on what you just did or whatever you tried, okay? So that way I will extract information from you as I go along. Cyberbullying is a major issue in today's social media networks, such as Facebook, Twitter, Instagram, Snapchat, etc. Nowadays, add few more. Well, since I made the problem several years ago, a few more got added, like, I don't know, TikTok, or Pinterest has been there for a while. Basically, it's social media. You are curious about the true population proportion, okay? You're curious about the true population proportion of social media users that were cyberbullied, okay? So you decided to take a survey of 300 people who use social media and asked them whether they have ever been cyberbullied. 80 responded yes. 80 of them out of 300 said yes. At 10% significance level, okay, that's your alpha. Test your claim that less than a third of the social media users experience cyberbullying. Less than a third of the social media users experience cyberbullying. So less than a third means 1/3, right? 1/3 is 0.33 roughly. Now, first off, you kind of actually have to do the null and alternative hypothesis. What is the null hypothesis and what is the alternative hypothesis? Even before you do the conditions assumption testing. So what is the null hypothesis and what is the alternative hypothesis? So you're testing that the proportion is less than a third, okay? Less than a third. So I'm gonna make it a nice number, 0.33. Less than a 0.33 or 33%. That's your alternative hypothesis. That means you're trying to test that. Your null would be complement of it, which is P is greater than or equal to 0.33. P is greater than or equal to 0.33. And that's your complement. Now is P is greater than or equal to 0.33 or P is greater than or equal to 33%. One thing you need to remember, null hypothesis, no, oops, let's write it somewhere here. Oops. Null hypothesis always includes the equality sign. Remember that. Equality sign. It always has to include the equality sign. That is the convention. Null hypothesis always includes the equality sign. Alternative never. Alternative hypothesis never includes equality. Alternative hypothesis never includes equality. Alternative hypothesis never includes equality. Null hypothesis always includes equality, but alternative hypothesis never includes equality. So, having said that, let's go ahead and do the null and alternative hypothesis first. Why am I doing it first? You will see. Null hypothesis is P is greater than or equal to 0.33, and your alternative hypothesis H sub A is that P is less than 0.33. That's what you're testing for. And your NP, that's why you need the P, because unless you do the null and alternative hypothesis first, technically you don't know what P is, right? You have to figure out from the information given in the problem what is P. P is 0.33. This equality sign tells you it could be 0.33. So N is the sample size, which is 300 times 0.33, which is greater than or equal to 10, obviously, right? And then NQ, which is N times 1 minus P, is equal to 300 times 1 minus 0.33, which is 300 times 0.67. Obviously, that is also greater than or equal to 10. So both of these conditions are satisfied. So that's step 1, and that's step 2. And step 3, you're going to do the calculation for test statistic. Test statistic, which is Z star is equal to P hat minus P divided by square root of PQ, P times 1 minus P, all of it divided by N. Now P hat, remember, we did it before, is X over N that you get from your survey. You surveyed 300 people and 80 of them said yes. So 0, 0 cancel out, 2 goes into this 4, 2 goes into this 15. So your P hat is 15 over 4 over 15. So 4 divided by 15, which is 0.2666. So I'm going to approximately say it's 0.27. So this is going to be 0.27 minus P is 0.33, all of it divided by square root of 0.33 times 1 minus 0.33, all of it divided by the sample size of 300. Okay, and then you simplify it, and what do I get? 0.27 minus 0.33 is this, 0.06 negative 0.06, then divided by 0.33 times 0.67 divided by 300 to the power 0.5, that's 0.027. So if we round it, is 0.027. So 0.06 divided by 0.027, which gives me, there's a negative here, so it's going to be minus 2.22. So your test statistic, Z star, is actually negative 2.22. So this is a number we will need in the next step, which is step 4. That's called critical regions. Critical regions. Okay. Now, before I get to the critical regions, I'm going to pause here and ask you, as I said, I'm going to extract information from you as I do the problem. So how many people actually got the first two steps? They go together. Did you guys, were you guys able to do the first two steps from the problem statement? Anybody got the first two? No one got the first two? Okay, then it doesn't make sense to ask the third step, right? Because if you didn't get the first two, you probably didn't get the third one. Am I right? Or somebody got the third step? Anybody got the third step? Okay. All right, so let's go ahead and continue with the steps here. Critical regions. Now, this is where you use the alpha significance level. The middle is 0. So let's take the background off. Middle is 0. And your alpha was, what was it? 10%, okay? Alpha is 0.10, all right? Alpha is 0.10. So we are doing left tail test because look, our alternative hypothesis is less than 0.33. So this area is gonna be 0.10, okay? And this is gonna be negative 1.28. Can somebody check this value? I think it's in, if I recall correctly, because I don't have the table on the screen right now. This handout does not have the table. Can somebody else look at the last handout and check it for me? Check the value. I think it is negative 1.28. So any volunteer? Anybody? AJ, can you find the value for me, please? Look at the standard normal distribution table. Look inside the table. Look for the closest value to 0.10. And it is, I'm pretty sure it's negative 1.28. I just want a confirmation. Anybody? All right. You guys look at it. So my critical region is going to be from negative, so CR, critical region is going to be from negative infinity to negative 1.28, okay? Negative infinity to negative 1.28. Now, let's look at our test statistics, so which is the step 5. Step 5, right? Conclusion. Step 5 is conclusion. Now, does this test statistic fall in the critical region? What do you guys think? Does this test statistic fall in the critical region, negative 2.22?
Yes.
Yes, it does fall in the critical region, right? So your critical region is going to be from here, right? From here all the way to negative infinity, right? So your test statistic is right here. Negative 1.28 is here. Negative 2.22 is somewhere here. Negative 2.22 is somewhere here. So test statistic Z star is equal to negative 2.22 fall in the critical region negative infinity to negative 1.28, right? It falls in the critical region. Therefore, we reject the null hypothesis that proportion of people who get cyberbullied is greater than or equal to 0.33. Okay, proportion of people who get cyberbullied is greater than or equal to 0.33. And that's the whole problem. Now we can do the p-value. So as you can see, the p-value would be area to the left of this. Now alpha is area from here all the way to infinity. Of course, p-value, we don't know. You need a software to do the calculation. P-value is less than alpha, which is 0.10, right? Look, 0.10 is the area, all the area to the left of this vertical line, all the area. Now p-value is all the area to the left of this point. Of course, this is less than the whole, right? That's the critical argument. P-value is this, right? And alpha is this, right? So alpha has additional area, which is this, which is like this region. So p-value is less than alpha. So you can say p-value, oh, I wrote it here. P-value is less than alpha is equal to 0.10. So we reject null hypothesis H naught. P is greater than or equal to 0.33. We reject the null hypothesis. And that's the general way of doing the problem. So you're seeing the second example, actually third one, because last problem I did it in the last class, I did it today, and now I'm doing another one. So any question about this problem, anybody?
I have a question.
Yeah.
How do you know if it's a one-tail or two-tail test?
Oh, okay. That's one source of confusion to students. If you're testing for greater than, okay, if the problem states that is greater than, okay, then you're going to be right tail, okay, or less than, then you're going to be left tail, okay. And if it says not equal to, then you're going to be doing both tail. When you're doing both tail, you have to take alpha, the significance level, you divide it by 2. But for greater than and less than, you leave the alpha as it is. It should be, to kind of answer your question, it should be coming from the problem statement. What are you testing for? Are you testing, is the problem saying something like this? Something is greater than, or something is less than, okay? Is something is greater than, or if something is less than. If the problem states, is it greater than, so then you'll be doing one tail test to the right. If the problem states less than, you'll be doing one tail test to the left. If you go back to the problem, actually, see here, test you came that less than, do you see? Less than a third. So that word or that expression tells you that you'll be doing one tail test, and the tail that you'd be doing is the left. On the other hand, if this, instead of less, if it were greater, you'd still do one tail, but you'll be doing the right tail test. Does it answer your question, Brenda or Brandy?
Yes, thank you.
Okay. Next problem I want to do is this. Exact same type. You are interested in finding out about the true population proportion of fellow students that plan to attend four-year colleges or universities after finishing their first 2 years here. Okay. Here means Hartnell College. That's what I meant. You asked 50 students and found that 30 plans to attend four-year institutions. Okay, so your N is 50. Your X is 30. As you read the problem, you can identify these things. At 0.05 significance level, test the claim, test the assumption that true proportion of students that want to attend your institution is different than 50%. Different than 50%. So, Brandy, to answer your question here, what is it gonna be? Can you help me out for this one? What kind of testing would you be doing?
Would it be, I don't know, 2? Or
Did
I
you
don't
say?
know. I said 2.
Yeah, you're right. It's two-tail. So what it is gonna be proportion or percentage of students that attend four-year school is 50% or different than 50%, or P is not equal to 0.5. That's what it is. See, if you see the problems a couple of times, it will start to make sense. P is 50% or P is not 50%. That's what it is. Okay. So this is going to be a two-tailed test, but right away that begs another question. If you have two-tailed test, you have to take alpha, which is what, 0.05, and you have to divide it by 2 because you have to distribute this alpha between the two tails that you are considering. So alpha over 2 is going to be 0.025. Okay. Now let me do the problem step by step. So your null hypothesis, this is your null H naught, and this is your H sub A. So number one, assumptions, the normality condition, making sure that the distribution of sample proportions is bell-shaped. The way you do is NP is greater than or equal to 10. Your N is 50. Your N is 50. Times P is 0.5. Where do you get the 0.5 from? Right here is 0.5, which is 25, right? Obviously, that is greater than or equal to 10. And similarly, you can show that NQ is equal to 50 times 1 minus 0.5. That is also greater than or equal to 10. So assumptions are satisfied. Number two, the null hypothesis, which we found, is P is equal to 0.5, and alternative hypothesis is P is not equal to 0.5. And this one decides which tail we are going to do. Is it greater than or less than or not equal to, meaning both tails. Now you will see, now I'm going to be doing the problems very quickly. Because once you do a few of them, the first problem I spent like almost 20 minutes on the problem. And the third one, you'll see not even 10 minutes. Actually, on the first one, I think I spent more like 25 minutes. Your test statistic, Z star, is going to be P hat minus P, all of it divided by square root of P times 1 minus P divided by N. P hat, by the way, is X over N, which is 30 over 50, which is 0.6. So your P hat is 0.6. So 0.6 minus P is 0.5, right? 0.5, all of it divided by the square root of P, 0.5, times 1 minus 0.5 is also 0.5, divided by 50. That's going to give you 0.6 minus 0.5 is 0.1, divided by square root of 0.5 times 0.5 is 0.25, divided by 50, okay? Which I can even simplify further. 0.1 divided by square root of 0.25 is, by the way, 1/4 times 1 over 50, which is, you don't have to do it this way. I'm just doing it for the sake of doing it. I don't want to use the calculator until the end. So there's going to be 1 over 200, which is, if you simplify it, is going to be z star, let's take the background off, is equal to 0.1 times, this is going to flip, is going to be square root of 200 over square root of 1, which is just 1, right? So it's going to be 0.1 times square root of 200. So what is square root of 200? 200 times 0.1, it gives me 1.41. Okay. So my z star or test statistic is 1.41. My z star or test statistic is 1.41. Now, step number 4, I'm going to do critical regions. Now, remember here, your alpha is 0.05. You have to divide it by 2 because we are going to distribute that significance level between the two tails. So that's going to make it 0.025 on the right and 0.025 on the left, right? And we know that this value is negative 1.96. This value is positive 1.96. Your critical regions are going to be everything from here all the way to negative infinity, everything from here all the way to positive infinity. If you write it out, it's going to be negative infinity to negative 1.96 union 1.96 to positive infinity. All right. Now you do the comparison. 1.41. So let's use red so that you can see it. 1.41 positive number. So it cannot be to the left of 0. It has to be to the right of 0. Does it fall in beyond 1.96? The answer is no, because 1.41 is less than 1.96. 1.41 is right here. So it does not fall in the critical regions. It doesn't fall obviously in the left region. It doesn't also fall in the right region. So that leads to our step 5 conclusion. Okay. You excuse me. Conclusion that test statistics Z star. So test statistic, not statistics, TIC. Z star is equal to 1.41 does not fall in the critical regions, fall in the critical regions, negative infinity to negative 1.96 union 1.96 to positive infinity. It does not fall in these critical regions. Therefore, we fail to reject, or we do not reject, fail to reject slash we do not reject the null hypothesis that P is 0.5 or 50%. And that is the whole story. Now, obviously, if you want to do the p-value, this value is going to be all the area to the right of this 1.41, right? So p-value, whatever it is, okay, it's going to be everything to the right. So everything to the right, which is going to be greater than the blue shaded region, which is going to be greater than 0.025. So p-val, to find the actual value, you need a software, okay? P-value, but visually you can see it. This has extra area right here, right? So it's bigger. P-value is greater than or equal to 0.025. So we do not reject H naught, the null hypothesis, that P is equal to 0.5. And that is the whole story, guys. And this is exactly the same thing or the same process that you are going to be doing for all of hypothesis testing. Exactly the same thing that you'd be doing for all of hypothesis testing. And that's it. Now, if you understood it, great. You are at a good start. The rest of the semester, or a good part of the rest of the semesters, would be an easy ride for you. But if you didn't understand it, what I did talk about last couple of days, including today, it's okay. You can watch the videos, ask me questions. That'd be great. Even after that, if it is not clear, no worries. I will be covering exactly the same concept on Monday and Wednesday as well, both of these days. All right. And we did the hypothesis testing for P. Now we are going to do hypothesis testing for M and hypothesis testing for standard deviation. M has two scenarios, sigma known and sigma unknown. So we are going to be covering both. But all of these hypothesis testing involve exact same procedure. If you understand one, the rest should be a repetition. You are going through the same process again and again. If you understood it, you're in a good position. If you didn't, you're still in a good position because there are more opportunities of being exposed to the exact same concept in different things. And I will do it again and again and again so that you'll get to the point you have no choice but to learn it. Of course, my assumption is that you participate in the class and paying attention on the other side. I don't see you, right? If you're just joining the video, joining the lecture and then not paying attention, then obviously you won't learn. So anyway, any question before I call the day off? Anybody? Any questions from anyone? Okay, that's all for today. Thank you so much. You guys have a wonderful weekend. Stay safe, stay healthy, do social distancing. Things are crazy in terms of COVID-19. Please stay safe and healthy and take care.
Thank you.
Thank you.
Thank you. Bye.